Hi, this is Chris, and we are here in Section 4 of SAT Practice Test 2, taking a look at questions 35 and 36. So for 35, they give us an equation and say Jane made an initial deposit to a savings account. Each week thereafter, she deposited a fixed amount to the account. The equation above models the amount A in dollars that Jane has deposited after T weekly deposits. According to the model, how many dollars was Jane's initial deposit? So this is something that I try to stress because it shows up so commonly. But when you have an equation that is a version of slope-intercept form, which this is y equals mx plus b. It's just represented with different variables. But what's important for us to note is that the intercept, when x equals 0, is exactly what we see here. And I'm going to put this in red and highlight it. But whenever you see initial, starting amount, initial, constant amount, initial, for these y equals mx plus b equations, initial means the y-intercept. That's something that conceptually we've got to know, and this is a great question to demonstrate it, because guess what? When they ask for that initial amount, you don't have to try to plug in values or do calculations or work with this equation. We're just going to look at the original equation. They want the initial. This is the initial. Our answer is 15. We bubble it in and we move on. So, important concept. Not the easiest concept, but once we wrap our heads around that, we're going to get a question like this correct in maybe 5 to 10 seconds, as opposed to having to take a couple minutes of trying to plug in numbers and come up with a variety of calculations to see if we can find a value. We know the value for this. All right, let's take a look at question 36. So here it says in the figure above, point O is the center of the circle. Line segments LM and MN are tangent to the circle at points L and N. And it says that if the circumference is 96, what is the length of minor arc LN? Okay, so again, when we're dealing with grid-ins, it's really helpful to just have a ballpark idea to make sure that the number that you come up with when you do your calculations is not off base. So if this entire circumference all the way around is 96, then since they're asking for this little piece in here from L to N, it should be something smaller than 96. If this is half, right, which would be 48, we should be looking at a value even smaller than 48 here. So that lets us know a ballpark approximation of what we're going to get. But now let's take a look at the actual math so we can find the exact answer. They say that these line segments are tangent. And when we talk about tangent to a circle, so if you're tangent to a circle, a concept that we need to know is that that forms a 90-degree angle with the radius. And whenever we can form a 90-degree angle with anything, our next instinct should be, 90 degrees. You know what? I know a lot of information about right triangles, about triangles with a 90-degree angle. Can I draw one? And here we can. We can split this in half. So each one of these halves is a 30, 60, 90 right triangle. And when dealing with right triangles, if we have one of our special rights, 45, 45, 90, or 30, 60, 90, that's really helpful because it gives us values. In this case, it gives us these 60-degree values, which means that total angle in the center there is 120. So I'm going to erase a little bit of this on the figure to make it clearer. So we're going to get rid of all that. And now let's just look at this angle as 120 degrees, as we saw from the triangles drawn just then. So if this is 120, with any circle, we can look at the central angle as a proportion or ratio of the total. So depending on what the question is asking, but here, 120 degrees out of 360, that's going to represent the same relationship of this desired arc length out of our total circumference. So here, they want the length of minor arc LN. And since they want minor arc LN, that's going to be that same proportion out of your total circumference. Now, since you have calculator, you can just cross multiply and solve 96 times 120 and 360 times x. But if you want to use a little bit of math skill just to quickly reduce, you can eliminate those zeros, and 12 over 36 is really 1/3. So that's going to make this calculation a little bit easier if you reduce it first. You get 1/3 equals x over 96. Now we cross multiply. 3x is 96, and x equals 32. And that's our correct answer here. And the reason I recommend reducing first is because I think for every SAT question that you see, it's always a good exercise to think, what if I got this question on a non-calculator portion of the test? And in this case, even if you got this on a non-calculator portion, if you reduce it first, it makes that math a lot more manageable. So that's it for questions 35 and 36 here on the Griddens. Up next, we'll finish out